Good afternoon, everyone. Sorry I won't be able to attend the conference due to another competition. Um, I'm glad that I'm being part of this conference. It's a great initiative, and I congratulate everyone for their effort to make it happen. This is my presentation. I'm presenting today regarding the design of low-cost and high-efficiency smart PV solar system for sustainable residential houses. Now, we start with the introduction. PV solar system converts sun radiation energy into electric current. The reason why we use renewable energy is for two elements. Number one is we need to save our environment. Worldwide, the United Nations and a lot of countries are supporting this effort, and they're working hard toward a sustainable and clean energy. Number two is the fossil fuel are depleting, so the fossil fuel will end. It's not going to stay forever. Some researchers say we have 200 years, some say less, some say more. So we need to find a different sustainable source. The sun, it's sustainable. Without sun energy, there's no energy, there's no life on this planet. Residential properties, solar system on residential property are increasing dramatically. We have multiple types. One of them is grid connected, where the solar feed the house and feed directly to the grid. One of them is solar system that feed the house and have energy stored and connected to the grid. So the house will have two power sources, actually three power sources, the grid, the battery, and the solar system. You have the standalone solar system where the energy to the house are formed using the PV solar system and the battery only. There's no grid connection. Now, to make the system valid and attractive, you need to make sure it's reliable, always available, and the quality of the power always maintained. The off-grid system, in order for it to be attractive to a lot of homeowners, has to have high efficiency, low installation cost, and at the same time, low maintenance cost. Maximum demand is what drive your house. Maximum demand is what drive the electric requirement for the PV solar system along with energy storage. So number one is we need to address what's a maximum demand. Maximum demand is your daily, hourly energy consumption for your house. Where you start from the maximum demand of your house, it's formed of the rated power of the apparatus and the length of operation. How many hours? Is it 1 hour, 2 hours, 3 hours? After we finish the calculation for our maximum demand, we need to understand that the system design must exceed your maximum demand to make sure that there is no shortage of energy. As we all know, the solar system, the solar energy exists during daylight, and also from a morning, midday, and afternoon, the sun radiation changes. The change in sun radiation also reflect in changes in the solar output. This must be taken into consideration during the design stage. This is an example of a house consumption. As you can see, the house consumption changes throughout the day as well. So some of them, sometimes it's exceeding large number, 5, 6 kilowatts, sometimes 10 kilowatts, sometimes 2 kilowatts. It depends on your energy consumption and your appliances. This is a figure will show that you have the energy generated during summer against the energy consumption. It's clearly shown that you have an area outside the generated energy from the solar, which is usually before 6 a.m. or 7 a.m. and then after 6, 7 p.m. This must be supported by the batteries. Now, to design the battery storage, we need to make sure that the battery storage is capable to take in the maximum demand and the number of days in case you are living in an area where heavily winter available. Like for example, let's say I have 2-3 days of fully clouded, I need to design for it. And that represents the number of days. The battery also depends, the battery life, one of the most important systems is you want to make sure that your system lives for longer. The battery's life is based on cycles. In order for me to determine the cycle, I have to understand the energy discharge of the batteries. So based on the energy discharge, for example, I wanted to discharge 50% DOD, I want 70%, that also will increase my battery storage capacity. Now, if the house is required to support multiple days, I have to make sure that the energy generated by the solar system capable to support this multiple days of energy, and that's what we need to update. Now, after we make sure that the energy, solar energy capable of producing sufficient energy to store the battery for the number of days required and to support the house, then I need to understand how can I minimize my investment? How can I make it cheaper? So this paper introduces stuff called introduce the priority concept. The priority concept, so during a storm event and during nighttime, I need to minimize my energy consumption to reduce the cost of my batteries. As we all know, the battery is the most expensive part for the system. And also will help you, the proposed diagram will help you to determine how can you determine the number of panels in series in parallel, because that's a very important when it comes to your inverter efficiency. Now, the case study that we used this case study, which is the house has a standard house, it has a dryer, toaster, kettle, lights, vacuum cleaner, charger, we have all this information. And the house energy consumptions, what we've done is we've done a standard arrangement without the priority concept, without load shifting, and this is what shows. So it shows that you have a lot of energy in the morning, night for air conditioning during summer, and then late after the sunset, late in the afternoon. So what we've done is we applied the priority concept for the homeowners, required the appliances, TV, television, light, refrigerator. That's what's really important under a storm area for a couple of days a year. And then the air conditioning for summer only during the daylight time. And we applied the load shifting, and this is what happened. So now what we've done is we shifted our power to midday, where the sun is heavily available for us during summer, and during winter, this 6,000 is because of the air condition. Remove the air condition, will drop down to maybe 2,000, less than 2,000 watt a day. And this will make sure my battery requirement is way smaller than the previous one. That's why the case study will highlight, using the diagram, how does it make it easy for you to design, to make sure that all your design all your design steps are met, and also how to choose the advanced charger controller inverter sizing along with the PV solar system. The priority concept shows the huge reduction in regard to the size of the batteries. The priority concept along with the load shifting also required an additional battery requirement make your investment cost is lower. The case study shows that 50% of the battery is required between using the proposed concept and the standard concept. In conclusion, the paper addresses the minimum design requirement for a PV solar system with battery storage. The case study supports the concept and shows evidence that battery storage size will be reduced by almost 50%. That this proposal reduces the investment, and if reduce the investment will make it very attractive to investors, which will makes it very green energy for every single house. If you have any questions, do not hesitate to send me an email, and it was a pleasure presenting to you.